All right, welcome to part 2 of week 6. We've taken a brief look at creating ND arrays and doing vector-oriented operations on ND arrays. We also described that all of the items within an ND array have to be the same data type. For ints, what we got was the int32 data type, which stores values roughly between plus or minus 2 billion. And for floats, what we have is a float64 data type, which happens to be the same size, the same format as the built-in float data type in Python. In this next section, we're going to take a look at slices of ND arrays and two-dimensional ND arrays. You can extend the idea of two-dimensional ND arrays to arbitrary dimensions, but we're only going to worry about 2 dimensions in here. Okay, so a slice of an ND array uses the square bracket colon notation, as we saw with strs and lists and tuples. An ND array is a sequence. You can index the individual items with 0 through n. One important difference, is that when you ask for a slice of an ND array, what you get is a view on that part of the ND array. You do not get an independent copy of that part of the ND array. Let me show why this is important. Let's create for ourselves an ND array A2 from the aRange function with values up to but not including 10. And whoops, what did I do? I just misspelled it. Okay. A2.np not range. It's try again. A2 gets np.arange 10. Okay. Okay, so there's our A2 with values from 0 through 9. And if I then ask for a slice, 2:6 in brackets, that's going to give me the items starting from item sub 2 up through but not including item sub 6. So I'm going to get a slice with these items 2, 3, 4, 5. However, that is not a copy of those items. It's actually just like a view or a window or a portal on those particular items. And if I say something like A2 sub 2:6 gets -8, this assigns the scalar value -8 to each of the items in that view. So that when I now look at A2, I see that each of these items that used to be 2, 3, 4, 5 is now -8. So that's a critical distinction between ND arrays and lists that you need to keep track of. If you want to get a separate copy of a slice, then you need to use the .copy method. Let's rebuild A2. So A2 is np.arange 10. Cool, did it right this time. All right. And now I'm going to say A3 gets A2 sub 2:6. So that's the same slice, but this time I'm going to ask for a copy. I'm going to ask for a copy of that slice. Forgot my Y. There we go. So A3 is a separate ND array from A2. And if I now modify A3 sub 0:4, okay, 0, 1, 2, 3, up to but not including 4, to contain -8, that does modify A3, but it does not modify A2 because A3 is a copy of the 2, 3, 4, 5 from A2. All right, so A2 is unaffected now. Okay, interesting. I have a typo. I have a typo on my slide here. These should be -8s rather than 8s, but I presume you get the idea here. Okay. Now, let's suppose that we want a two-dimensional ND array rather than just a one-dimensional sequence of values. There are various ways that you can create two-dimensional ND arrays. One simple way is to use a list of lists rather than a single-dimensional list or single-dimensional iterable. I'm going to create this list of lists called M35, and I'm much too lazy to type this, and I'll make too many typing mistakes, so let me copy and paste instead. Come here. There we go. Got it. There we go. So I'll copy that and paste it in. Now, because I am within this outer square bracket here, when I hit the Enter key, it doesn't matter that I'm not indented. So I'll just leave that lack of indents. Here's my closing square bracket at the end of my list of lists. So this is going to work fine. And M35 is now a list of lists, and each sublist has 4 items within it. Pardon me, 5 items within it. The name M35, in fact, is, I chose that to remind myself, which I forgot, obviously, but I chose that to remind myself that I'm going to think of this as 3 rows and 5 columns. Let me now create A35, which is an ND array. And I use np.array with my iterable M35. And okay, so there's the display. The default representation is displayed for the ND array A35 as a nice two-dimensional array with 3 rows and 5 columns. In fact, ND arrays have a shape attribute that you can query that will return to you a tuple. Notice the parentheses indicating that this is a tuple, telling you how many rows and how many columns there are within A35. And I can, because that's a tuple, I can say A35 sub 0 to get the number of rows, and I can say sorry, I mistyped that. A35.shape sub 0 to get the number of rows, and A35.shape sub 1 to get the number of columns. Now, normally in real life, you wouldn't probably manually type in this two-dimensional array of values. Most commonly, you would have pulled this in probably from a comma-separated value file or some other kind of text file, or possibly obtained this from a database. I have a file that is available to you called observations.csv. And what this file contains, let's imagine, is information about patients in a doctor's office. And I can actually open this file. So let me say File, Open. And it's not a .py file, so I'm going to have to look for all files. Here we go. Here's observations.csv. And it's a little too big to fit. So let me shrink it. And, well, I'm still not sure. Well, I think, well, no. I'm being an idiot. Let me shrink the font size. I will shrink the font size to 25 should do it. There we go. I'm easy to impress. There we go. So now I've got the whole thing fitting within our video window. And let's imagine that these are ages in years, heights in inches, and weights in pounds of various patients for some doctor's office. Okay? Now, I can read in that CSV file by using a function named genFromText, generate from text, which is a facility built into the NumPy module. Let me do this. So I'm going to create a CSV. There's nothing special about this name. It's just it's an array that I'm building from a comma-separated value file, is all that means. And I'm going to say np.genFromText. And notice the boodle of options that I have available to me for configuring how to call this function. The first thing I have to give is the file name, so I'll do that. Observations.csv. I also have to specify the delimiter between the fields in this file. For whatever reason, genFromText is not smart enough to understand that a comma-separated value file with a .csv extension is delimited by commas. So I have to tell it that the delimiter is a comma. And that's that. Now I'm going to cross my fingers and hope that there's no other parameters I need to specify. Poof, it worked. So if I now display a CSV, all right, well, it goes zooming off the top of my window, but that's okay. I do have this two-dimensional ND array with ages, heights in inches, and weights in pounds of several patients. In fact, ACSV.shape tells me that this array has 20 rows with 3 columns. I can see just the top 5 by asking for a slice of the top 5. This is from 0 up to but not including 5. All right, so there's the top 5 patients in this data set. I can also later on take an ND array, some arbitrary ND array, and I can save that into a comma-separated value file using the function np.saveText. I give my file name, and in order to make Windows happy, or Linux or Mac or whatever for that matter, I'm going to give the file name a .csv extension. But I do also need to specify the delimiter in order to save the file. All right, I'm not going to bother to do that. Just trust me that it works. And let's take a look now at what we can do with two-dimensional data. Now, for the purposes of these upcoming examples, rather than using this patient data, for the most part, we're going to take a look at some two-dimensional ND arrays of some random numbers. I also want to illustrate the random number facility that the NumPy module provides. If I say np.random, that accesses the random submodule within NumPy, and from this random module, there are a lot of different probability distributions that I can draw random numbers from. I've got a beta distribution, a binomial distribution, chi-square. I've got all kinds of things, exponential. Let me access rand n. N here in this name, rand n, stands for normal or Gaussian distribution. And what I'm going to request is 3 by 5 random draws from the standard normal or standard Gaussian distribution. So the standard normal has mean 0 and standard deviation 1. When I hit the enter key, I get back this 3-row, 5-column ND array. And these are random draws from standard normal. Now, by default, these numbers are displayed out to 8 places, but that's really annoying to look at. It doesn't fit on my screen very well. So here's another cool facility. And this time I'm going to store the results into a variable an. I can say np.random.randn, 3 rows, 5 columns, and I can say round those to some number of digits. In this case, I'm going to ask for 3 digits after the decimal point. And so here is my an. All right, now my an being displayed here is not the same as the one that's shown in the course notes. So I'm going to cheat and copy and paste so that my random examples are the same random examples that are shown here in the course notes. And this is very easy to do. I can simply say an gets np.array, and notice that embedded within this array, ND array representation, I have a list of lists. So I can copy and paste. Whoops. It's going to be a little difficult, I guess. Let me see if I can figure out how to do this. There we go. There we go. All right. So that gives me all the numbers. I'm missing some square brackets, but that's okay. I can just manually type those square brackets myself. There's my 2 square brackets. Now I'm going to paste in all those numbers. And now I need to type the closing 2 square brackets and the parenthesis. Okay, so now I have, by copy and paste, I have exactly the same random numbers as the random numbers shown in the notes. Okay. Now, we've already seen how to get slices of one-dimensional arrays. Here I have A1. Actually, A2 has more values in it. And we saw that I can say things like A2 sub 3:6 to get a slice, or technically a view, on those values 3, 4, 5. If you have a 2-dimensional array, then you can slice in both dimensions by using a comma between the 2 dimensions. So here's my array an, which is 2-dimensional. And if I say an sub, well, let's just access one individual value to begin with to illustrate. So here we have this minus 0.26. Where is that? That is in row sub 1, right? Because remember that the rows count from 0. So row sub 0, row sub 1. All right, so that's in row sub 1. It's also item sub 1 in that row. It's column sub 1. So this is an sub 1 comma 1. Is that minus 0.26. Now, if I want a 2-dimensional subarray of this ND array, I can use slices in both directions. So if I say 1 colon for the rows, that means to give me starting from row sub 1. All right, so I'm not going to get anything from row sub 0. I'm going to get things starting from row sub 1 up to the last row in the ND array. And then for columns, let me say colon 3 as an example. What that means is all of the columns starting from column sub 0, 1, 2, but not row 3. Okay, so what I'm going to get in particular by asking for rows 1 colon, columns colon 3, is this lower left, this lower left corner of the array. I get row sub 1 and row sub 2, and within those rows I get columns sub 0, 1, or 2. All right, here I'm displaying those columns. And in the next line of code, I'm modifying those values. Remember that this is a view on the underlying ND array. It's not a separate copy of those items from the ND array. So if I say A colon comma colon 3 plus gets a 7, now all of these items here are going to have 7 added to them. Okay, and so all of these values in the lower left corner have been increased in value by 7. So we've now taken a look at the idea of a two-dimensional ND array, and we've seen how to read in a two-dimensional ND array, or generally speaking, any dimensional ND array from a comma-separated value file, and taken a look at how to access subparts of that array using slices. Very often when you pull in a two-dimensional matrix of values from some data set, you're only going to want to deal with certain parts of that. For example, you may have information about, let's say, a COVID infection rate for rows representing states or counties and columns representing days of the year. You may only be interested in the data for California. You may only be interested in the data for April. And so by using slices, you can pluck out from that huge rectangular data set the subpart of the data that you care about. All right, so the lab for this material will give you some practice with slices and two-dimensional ND arrays.